Good morning, fourth graders. Just to review with you, we are in chapter 12, and the lesson that we're doing today is 12:7. So before I left you on spring break, we had just completed a lesson titled Improper Fractions and Mixed Numbers. And to do this lesson today, which is modeling of addition and subtraction of mixed numbers, you really have to know these two terms really, really well. And I wanted to review with you just quickly. So mixed number is just that. It's mixed between a whole and a fractional part. So if we said 3 that's our whole number, and then if we threw a half on here, 3.5, that is now a mixed number. You can take these mixed numbers and turn them into improper fractions, which means the numerator is heavier than the denominator. So technically, you're going to have a heavy top and a not so heavy bottom. That's how it works. You can take any mixed number and change it into an improper fraction and vice versa. So here, if we looked at this is the simple algorithm I showed you. I call it the circular motion. So it is multiplication and addition. So you have to multiply 2 times 3, which gets you 6. Then you add the 1, which is 7. So 7 over 2 would be an improper fraction, and then this would be that mixed number converted. And you can do it backwards if you want. It's basically 7 divided by 2, and you know it's going to go in 3 times with 1 left over. Okay, that's the very quick and nitty-gritty lesson. I just wanted to jump right into the model and the algorithm today. So here's what you're going to see. Go back to learning how to add and learning how to subtract, and I'll keep it really, really simple for you. 2 plus 1. See how it's stacked and linear? So we know that that answer is going to be 3. If we change the operation, I want you to be very careful today to pay attention to the operation. It's 2 subtract 1. We are going to have 2 different outcomes in this one. So 2 subtract 1 is 1. So again, pay attention. Notice that I'm working 2 in this fashion. So you've just stepped up now to an upper level math group, which is now mixed numbers. So I'm going to draw for you and model the algorithm at the same time. So we're dealing with 3 3/4. That's a mixed number. The operation here is going to be addition. We're going to add it to 2/4, 1 2/4. So notice how, again, it's stacked. Notice that there's a whole number column, and then there is a fractional column. It gets a little tricky here. So visually, I'm going to make it really fast. I'm going to use bars to represent wholes. So at this one, we have 1, 2, 3. And then since we have 3/4, I know that that's a bar, and you could divide it into 4. So half, half again. So that means you erase this portion. So this is what this looks like. Really quick. You could draw the box and make it faster. Down here, we've got one whole and another one that says 2/4. So I'm going to divide it in half. So another term for 2/4 is 1/2. So it's really these things added together. So you can go 1, 2, 3, 4. So we have 4 wholes, and then we have 1, 2, 3. If you were to, you have to. It's kind of tricky. So you have 3/4 over here. So if we rewrite that again, and then we have to get this one fraction left over, 2/4. Okay. And then you could add them together and get 5/4, which we know right away we can't keep because that's an improper fraction. So you're going to have to convert this to 1 1/4. And I'll show you the algorithmic way just for the sake of speed. You'll have 3 lessons this week that kind of review this whole thing. So let's go back to the original column work. So we have like denominators, which makes this problem really easy. In 5th grade, you're going to have unlike denominators, and there's a trick you have to do in order to even begin it. You have to translate it. So let's start. 2 plus 3. You said that, 5. Uh-oh. So again, I was talking about really needing to know what improper fractions are and how to translate them. So in this column, I'm going to draw this imaginary line. You don't necessarily have to do this. We're dealing on this side with an improper fraction, so the easiest way to do this would be to translate it right away. It's a division problem, if you can recall. I'll just save some steps for you. It's 5 divided by 4. That's what that means. And we know that it goes 1 time with 1 remaining. These, again, are the 3 important parts to this whole thing. Looking at the quotient, 4 will go into 5 1 time with 1 remaining, and we have to keep the same denominator at 4. So 1 1/4 is what this means translated. So keep that number in mind. Over here, let's go over to the whole number column. 3 plus 1 is 4. So now we come over here, and you could line it up again if you'd like, or you can do horizontal adding, which I kind of like. 1 1/4 Okay, so now we're going to add our whole numbers. 4 plus 1, 5, and we're going to bring over the fraction that remains, a quarter. So the answer to this problem, translated all the way back again, would be 5 and 1/4. That's adding. Subtraction is a little bit trickier. Okay, let's take you on the subtraction journey. All right, we're going to again put some mixed numbers here. Okay, note the sign. You're probably going to see a problem right away. Yep, we're right. The whole numbers look right in subtraction, but these do not. These are the fractions. You're going to notice that this fraction here is much bigger than this fraction up here. Oh no, in subtraction, that means you have to regroup, right? So we're going to go over to our whole number column and say, hey, 2, I just need to borrow a whole from you. So we're going to get a whole and bring it over. So we're going to go 1, bring over 1 whole. In order to do that, we just change its name. We say we borrow. A long time ago, we learned borrowing, but it's now we're grouping. We're going to take this 1 whole and we're going to translate it. So what does it look like? Well, we know another name for 1 whole using the same denominator, because this denominator is really important. I always stress that. You're going to bring it over and you're going to call it 8/8. 8 doesn't look good there. So 8/8 is another name for 1 whole, and that's what we took right over here. I'm going to add it to what's previously here. That way it'll give me enough so I could subtract this bottom number. 8 plus 2, 8, 9, 10. And I'm going to keep the same denominator, bring over 8. Now I have 10/8 and 7/8. Now I can actually do that problem. So to save kind of how I did that, keep it over here. I'm going to bring it back. I'm going to rename it over here. You could actually just keep writing it over here on this side. Okay. Now we have 7 subtract 10, which is 7, 8, 9, 10, 3 eighths. Okay. And 1 subtract 1 is 0. So truly what happens here is we just have 3/8 left. In a model, we have, I'm going to show you, the real way to do it with a model, not just my sticks, because subtraction's a little trickier. So in this case, I have 2, and since 8 is our denominator, make a whole, and then I'm going to divide it into 8. So there's 4, again, and divided by 2. Okay, so we have 8s. 10/8 actually looks like there's 8/8. There's our whole we brought over. Let's add our 3 more that we had previous. Okay. I think the original problem, if we went back to it, was this was 3/8 right here. So I'm going to add, just keep that there. So all of these equal 1/8. And to save time, I'm not going to label each and every one of those. So we can do some subtraction. So we're going to subtract 7/8 from 10/8 to start with. So we go 1, 2, 3, 4, 5, 6, 7. Okay. We also had to borrow one of these to make it. So we have to cross through one of those. So we now are remaining, oops, does that? Doesn't seem right. My model doesn't seem right here, does? If I started with my original problem, I apologize. 2, so we have 1 whole, 1 whole, and then we had, of course, 10/8, which would be this again, and, oops, 3/8. That was 2 and 3/8. Okay, there we go, pardon me. 2 and 3/8, and then the bottom was 1 whole and 7/8, so almost, I'll erase when we're done. There's 7/8. Okay, so if we were subtracting 7/8, so we're taking this and you're going slash through, and then we're going to take, we have to take this whole 1 and translate it into 8s. And then we have to subtract that 7 from it. 1, 2, 3, 4, 5, 6, 7. And then we're left with, we should be left with 3/8.
Hold up, you gotta plan.
You gotta plan? Oh.
Plan.
This is a tricky algorithm. Your parents have seen it. I want you to follow the Learning Bridge too. Watch the video in Pearson. When you're all done with the lesson, you've practiced, and you've even checked the key. The key will come up tomorrow morning. Grade it, and then submit your work. If you feel so confident, you can go ahead and take the quiz today if you'd like, the digital quick checker. All right, thanks you guys. Sorry for the quick lesson. Let me know if you have any questions. Just put them in an email.